solution to which of the following systems of equations?
Okay, so when you're doing a question like this, be really clever. By clever, I'm talking about, I'm not calling out names because I'm recording, right? Okay? If you look at these two columns right here, do you realize the second one is a lot shorter? So I'm going to worry about this guy, this guy, this guy, and this guy. Now, are they all distinctively different? Yeah? So that's good. So if I could find what's happening on the bottom, who cares about the first one? It's going to work out no matter what. So then I'm going to pick out one that's not going to work out just because and show you the one that is going to work out. Let's test part A. So it says my order pair is A comma B. So all the A's are represented by 4 and B's are represented by -5. So when I plug it in, we have -5 is my B is equal to the A 4 minus the 1. Is that a true statement? 4 minus 1, is it really -5? Nope. So then let's go to one that is actually correct. Go to the last one. We have 1 is equal to negative of the A, it's going to give me -4. If that makes sense, give me a nod. Okay? And then if I get negative of the B, what do I get? +5. Is -4 plus 5 really 1? Done. There's no reason to test anything else because everything is distinct in its own way. Y'all good with that? Okay? So don't work too hard. Work smarter. Okay, moving on to the next one. We're going to look at question 6A. On 6A, Pierce, go ahead and read that one.
A store sells 35% of its inventory of X carpets in a day. If a customer then buys 3 more carpets, which of the following represents the number of remaining carpets left in the inventory?
All right, this question has to relate with what we talked about last class. Y'all remember the question where somebody was baking and they did not want 1/3, but they wanted to use 2/3? Yeah. Maybe not? You were absent, that's why. All right, so what that means is the store sells 35%. And I want to talk about how much is left in the inventory. So let's kind of think about it. If I have no 35%, how many percent is in the inventory with me? 65%. And our 65% in decimal is 0.65. Of the inventory, the word of is the product of. Now, just by looking at that, let's start eliminating. A is gone. What else is gone? Nothing else pretty much, right? Okay. Now, from here, a customer walks in and goes, hey, you're not done. I'm going to buy 3 more items. If that customer buys 3 more items, do I have more inventory by 3 or do I have less inventory by 3? We have less inventory by 3, so -3. And that's going to match which one? B. And these end up being hard just because you're not looking at what's being sold, what's being kept. Okay, it's all about the logic behind this. Okay, moving on to our next one. We're now looking at algebraic reasoning. All right, Ty, let's read number 3, or question 3 of the algebraic reasoning.
Shown in the equation above, T represents the boiling point of water in degrees Celsius, and X represents the height above sea level in meters. If T equals 96 Celsius, what is the value of X?
Okay, this one's straightforward. All I need to do is plug in T into this guy over here. So let's do that together. Let's have 96 is equal to 100 minus X over 305. And I'm going to kind of work on this in a clever form. I want to move the whole fraction over to make it a positive. You don't have to, but that's working smarter. And then I want to move the 96 over to the other side to make 100 minus 96 is how many? 4. And the last step, what do I do with 305 and the 4 to solve for X? Not divide, but multiply. Let's do our the multiplication. So we know 5 times 4 is 20. 4 times 0 is 0 plus 2 is 2. And then we have 1220. D it is. Okay? So even though some questions might be wordy, it could be straightforward like this, which is great. Okay? My only guess is if that number was really ugly decimal, the calculator should pop up, but you never know, right? Okay? All right, let's move on to our second algebraic reasoning. Ooh, factoring. Y'all did a bunch of that in Algebra 2 and Algebra 1. All right, Carson, let's read this question. Okay, let's start with the easy one. Is condition 1 or 2 easy one? 1. So let's kind of recall. If you're like, I forgot how to factor, it's okay. Here's a quick teach. As long as you have x squared without a number in front, this could be a shortcut, meaning I have x and x. And I'm going to put the understood 1 in front of the x. So the idea is, what two numbers can I multiply to get to -6, but combine to get +1? 3 times what? -2. Do we agree on the -2? So let's see if that is true. If I add these two together, I get a 1. If I multiply these two together, I get a -6. Do we agree on that? So we know condition 1 is met. So it can be A or it can be C. Y'all good with that? So then we have to test the second one. On my second one kind of gets a little annoying because I have some coefficient in front. Hopefully y'all remember grouping. If you're like, I forgot grouping, here's the idea. Draw me a big X, and you multiply the A and the C, which is -4, and you keep the B value as it is. Okay, same rule applies. What two can I multiply to get to -4, but combine to get -3? -4 and 1. Do we agree on that? So here was a rule back in Algebra 2. You keep the original term on the first term, and then you split the middle with the two clever numbers, but you cannot forget the x. And then you keep the last value, which is -2. And there's actually a way to self-check this. When I group these two values, what can I take out on the first set? 2x. And then I have remaining x minus 2. Do we all see that? On the next one, can I take anything out? No. So we're going to take out the understood 1 and leave x minus 2. And we know we've done the right thing when these two values are identical, which it is. So my final answer is the outsides and then the insides being multiplied. So if you notice, the factor of x minus 2 happens on just one or both? Both. Okay, questions on that piece? If that's good, give me a thumbs up. And these are questions that you picked out, so it's pretty good. All right, let's go on to our third category, is our geometric reasoning. Okay, on my geometric reasoning, Vivi, let's read number 10 of this category.
What is the area of the shaded portion of this picture?
Okay, so if I'm looking for just a frame portion, isn't it big minus small? Some of you guys might be like, kind of tedious to show too much work, but I'm going to. Here's square 1 and square 2. Squares have the same sides. So all I have to do is do 2w squared minus z squared. But of course, that's not part of the answer. I need to further simplify this. What is 2w times 2w? 4w squared, so it's got to be how many? Which one? D it is. Okay, are we good with this one? We're good, give me a nod. Okay, the next one from the geometric reasoning category. Boom. This one sounds like Unit 8 similarity. All right, let me try to fit this. All right, Nick, let's read this category.
Triangles ABC and triangle DEF are similar right triangles. The ratio of AB DE is 3 to 7. If the hypotenuse of the smaller triangle is 4 meters long, how many meters long is the hypotenuse of the larger triangle?
So when they give you the ratio and also state that they're similar, it does not matter where you put the 3 and the 7 or any numbers, as long as you have the similarity proportion correct. But just for those of you guys that are visual learners, I'm going to draw me a triangle and a larger one. And let's see how I knew the second one had to be a larger one. AB is part of my small one. 3 is part of my small one. So I drew one smaller. Everyone good with that? Okay. So I have right here. And again, the way you name it does not matter as long as you're going in a consistent order. So the way I'm going to go is from top, bottom to right. You could say top, right to bottom. That's fine. And then we have DEF. And then they said smaller triangle has a hypotenuse of 4. And I know my ratio is 3 to 7. So I'm going to write 3 over 7. Is my value of 4 part of my small or big triangle? Small. 3 is a small number. I'm going to put that right here. So that means my variable x is going to be on the bottom. And if I cross multiply, we have 3x is 28. X then must be 28 over what? 3. Does that look like a calculator portion? If the answer is already in that form? Probably not, or most likely not. Y'all good with this? Okay, give me a nod if you're ready for the next one. Looks like I might be able to get through all 8. All right. Whoever chose number 3, good on you. Now, there could be many ways to solve this problem. I'm going to show you algebraically just because I'm a math teacher, okay? If you see it differently with ratios and proportion, use it. All right, for this one, let's see, Savannah, let's read the pie chart category.
Adam, Shruti, Jordan, and Lynn divided the cost of dinner as shown in the circle graph above. If Adam spent $6 more than Shruti on dinner, how much did Jordan spend?
So we're comparing our 2 students, Adam and Shruti, and then we're asking about a third guy, okay? That might be where the confusion might be, but let's see if I can break this down. So we know Adam spent 6 more than Shruti, so I'm going to write on here A as in Adam. Whatever Shruti spent plus 6. Is everyone good with that? And then I'm going to go to Shruti and say, well, she spent X amount of dollars. So far, so good? And then let's do our proportion. My proportion is going to be X over X plus 6. I can reverse that if you want, but I like to have the simple one on top just because that's my preference. And then X is representing Shruti. How many percent was Shruti? 40. How many percent was Adam? 45. But just in case this could be a non-calc, can I further simplify 40 and 45? Yep. So I can make that into X over X plus 6. And they can both be divided by 5, correct? So it could be what over what? 8 over 9. So let's do our tedious math. 9x is equal to 8x plus 48. So then when I move the 8x over, what's my x value? 48. So that means Shruti spent how much? $48. So then let's kind of look at it by logic on the next one. Okay, everyone look at 40%. If I take 40% to get to a 10%, what operation am I doing? 40 divided by 4. So 48 divided by 4 is what? 12. Boom. Jordan spent $12. If you have a different method, use it, okay? Because it could work out in multiple ways. Okay, the next one. Also a good one, so whoever chose this, give yourself a tap on the back. Good on you. All right. This one's simply stating the fact. Okay? Camila, let's read number 2 of this category.
In which of the following histograms is the median most likely equal to the mean?
Okay, the median is equal to the mean. So I'm going to circle all the medians at the moment. From 0 to 100, it's representing on all of them. Where's my median? 50, okay. And then let's kind of think about the definition of average. Average basically means, so when you're taking your tests or quizzes, you have like some low, some high, some low, some high, right? Average simply means if I were to squish them all together in one level, what is the same grade, okay? And if I were to split this exactly through the middle, let's see what would happen. I have the same amount of shape on the left as the bottom that I have a gap for. Same amount of shape on the top as the amount that I have for the gap for. Can it actually fold down and create a level playing field? Do y'all see that? Yes. So that means that is the average, which is equal to the mean. So here's the idea. For those of you guys that are probably thinking about stats, when the mean and the average are always equivalent, it's always a symmetrical curve, or in this case, symmetrical graph. Do we all see that? Okay? All right. I think that was the last one.